All right, good morning and good afternoon or good evening, depending upon where you're at. This is Jason Straight with the Cloud PaaS Virtual Group. Today our presentation is benchmarking in the cloud, and we have Gianluca doing the presentation today. So this virtual group is brought to you by Spotlight Cloud from Quest. It's the first Azure-hosted database performance monitoring solution focused on SQL Server customers. Spotlight Cloud's been around for quite a long time. They got the ability to leverage their scalability, performance, and built-in security, and they're doing all of that within Azure itself. They've been doing this for years and years, and they have plenty of insight into how to best help you performance tune your databases. So if you are looking for a performance monitoring tool, I do recommend you go and take a look at Spotlight Cloud. Benchmarking in the cloud with Gianluca Sartori. And let me make a presenter. All right, you are now the presenter, Gianluca.
Okay, let's see if I am showing the correct things. You should be seeing my slide deck, right?
Correct, that's what I'm seeing right now.
Okay, so hello everybody and welcome to this session, and we will discuss today benchmarking in the cloud. So before we go, a few words about me. My name is Gianluca Sartori. I'm an independent SQL Server consultant. I've been working with SQL Server for a long time. The first version I have worked with was version 7, so really a long time ago. Currently, I'm working as a DBA for a famous Formula One team in Italy, the one with the red cars and prancing horses. And if you want to read my blog, you can find it at spaghettidba.com. If you want to follow me on Twitter, my handle is @spaghettidba. So the agenda for today. First of all, we will see benchmarking scenarios. So we will see why we want to take benchmarks and what are the possibilities here. And then we will see how do we do this. So what are the tools we can use and the challenges involved in using any of these tools. And then we will move to the cloud where we will see that we have even less tools and things get even more complicated. And then we will have some demos of a tool that I built specifically for this. So first of all, definitions. What is a benchmark? It is something that describes the performance of a system in a given scenario, which could be any scenario. It could be how my production server is performing right now, but it could also be a different scenario that I want to evaluate. So it could be the description of a system where I change something at the hardware level, like buying new storage, and see whether that performs better or worse than the one I have. Or maybe it could be a scenario where I upgrade the software, which could be Windows or SQL Server. I move to a newer version. I want to see whether I have performance regressions or things are always getting better. Or other scenarios I could evaluate are something that have to do with the environment itself. So I move my last few bare metal servers to a virtual server, and I want to know upfront what are the resources I need in order to have the same level of performance I have with bare metal. Or maybe I want to migrate to a different data center with a higher latency, and I want to know whether the latency is acceptable for my workload or not. So all these kinds of considerations for my environment. But benchmarks are also useful for rating your tuning efforts. So you do something at the server level, like moving some knobs at the server level to change some configuration options, and see whether that has a positive or negative effect on the performance. Or maybe at the database level, you add, remove indexes or change something inside your stored procedures, your queries, and you want to know whether that has pointed you in the right or wrong direction with performance. So what's inside a benchmark? As we have seen, it's all about performance. So it has to contain a description of the performance, or the general performance of the workload we are trying to describe. So it will have to contain some information about the overall performance, like the number of batches per second, or the CPU consumption, or things like the wait stats, which are a good way to describe what the instance is waiting on. So what is generated, what kind of waits are generated by the workload. But also we have information that is more specific to the workload. So the queries itself that are found inside the workload. And for each of these queries, we will also capture some performance indicators like the duration, the CPU, the number of reads or writes for each of the queries inside the workload. So why do we do this? How does it work when we want to take a benchmark to compare performance? So basically we will have something like this. We will have a production instance where we will point our tool to capture, and this tool will capture all the queries that we run against our production environment, and for each of the queries we'll capture the workload with the performance indicators for each of the queries, and also the overall performance data. So what we do next, we will have another instance, a test instance, which is the target for our benchmark, so the second instance that we want to measure with a benchmark, and we will have something, a tool that is able to replay the workload inside the benchmark against the target instance. And while we are replaying, we will also have another instance of the capture tool, this time pointed to the test instance, and it will again capture a second benchmark with the performance data, and the performance data correlated with the single queries. And what we want to do at this stage is compare the two so that we can catch some interesting things like regressions, queries that were performing well in the production environment and are not performing so well in the test environment. This is particularly interesting if you want to do an upgrade and you want to capture regressions before you go live. Other things you want to capture here, scenarios that you don't want to run in production. So things that stop working because you move to a newer version and you are using a feature that has been discontinued, or other things you want to find at this stage is whether your tuning efforts are good or not. So your production environment contains your present situation, and your test environment contains a situation when you have moved some of the knobs at the server level, and you want to know whether that has a positive or negative effect on your workload. So if you ever tried to do this, you probably know that this is hard, not impossible, but a bit complicated, because you have to know how to do this at all the stages. So when you're capturing the workload, you will need a tool for that. You will have to configure it properly. You will have to capture exactly what you need. And also when you are replaying, you will have to choose a tool for that, and you will have to configure the tool correctly. And also for comparing the results, you will have to choose again a tool, and it again will have to be configured correctly. But the main challenge here is choosing the right tool for the job. Throughout the years, we had many tools for this, like RML utilities, distributed replay, profiler. So we will try to go through the tools here and see what are the strong and weak points of each. So regarding capturing the queries, the first tool that probably comes to your mind is Profiler, because it's a tool that's been around for a real long time, but it's not really suitable for this, because Profiler is an interactive tool. It shows you the queries while you're capturing, and this interactive nature of the tool has negative impact on the server. If you point it to a very busy production server, it will probably end up slowing down your workload. So if you want to use something that has a minor impact on performance, you will probably use extended events. Extended events is a technology that Microsoft has produced exactly for having low performance overhead. So it seems to be the appropriate choice in this case, but it has a couple of shortcomings. First of all, the files it captures are pretty big, and also it is not compatible with all the versions of SQL Server. Extended events have been introduced in SQL Server 2008, but they were not a complete replacement for SQL Trace until SQL Server 2012. So if you're working with an older version of SQL Server, extended events is not really what you want to use. So in this case, for all the versions, the tool you will probably end up using is SQL Trace, which is a bit old school. It is deprecated. Hasn't been touched since SQL Server 2008, but it still works pretty well, and also has the ability to work with many benchmarking tools that you can find on the web. So it's still a very good choice. Regarding capturing performance information, the main indicators here are found inside performance counters. So you will have basically two types of performance counters. The Windows general performance counters that describe resource consumption, like CPU or disk memory usage. And then you have performance counters that are more specific for SQL Server, like number of batches per second or page life expectancy, things like that. So how do I choose the appropriate performance counters for describing SQL Server workload? There's a tool that helps you here. It is called PAL, and it is basically a PowerShell script that is capable of analyzing a BLG file, so a file that contains performance counters, and produces some reports. It also contains a list of meaningful counters and a range of acceptable values with thresholds for many Microsoft applications, including SQL Server. So if you go to GitHub, you can download it, and you will find inside all the meaningful performance counters for SQL Server. Regarding analysis, what tools we have here? The main tools that has been used for a long time for benchmarking is called RML utilities. It is actually a collection of tools, but the main tools for this are called read, trace, and reporter. Read, trace is a command line tool that is able to, well, read a trace, as the name suggests. So it scans a trace, goes through all the events found in the trace, and computes some statistics about the queries found inside the trace, and writes the results to a database that you can later point to a tool that is called Reporter, and this tool produces some reports that shows you how the workload performed. We have also other tools like SQL Nexus, which is also based on RML utilities, or ClearTrace, which is another nice tool that can do pretty much the same as read, trace. It is used for one-off analysis of traces, and it also has the abilities to normalize the queries, which means that it replaces the constants, all the literals you have inside the queries with some placeholders so that identical queries that differ only by the values found in the constants will be treated as the same queries. So it is able to aggregate the same queries even if they contain different literal values. What else we have here? For analysis, there's still PAL, which is able to perform analysis of performance counters based on the thresholds found in the threshold files inside the project. And also we have DEA, which is a pretty new tool. It is called a Database Experimentation Assistant, and it is based on distributed replay, but now I'm told that the newer versions are based on OSTRES actually. And it is able to display very nice charts made with R, so it's pretty visually appealing. And regarding replay tools, again, we have Profiler, which is probably the simplest tool to replay a workload, but it has the same shortcomings found for the capture part. So it is an interactive tool. It is more suitable for capturing, for replaying a workload in an interactive way. It has the ability to set breakpoints for troubleshooting particular scenarios. So it's not really suitable for performing replay of a whole workload. RML Utilities contains a tool for replaying a workload which is called OSTRES, and it has two possible ways of replaying a workload. One is called stress mode, and this mode, it runs the queries found in the workload one after another, so there is no pause after each query. And then the other mode is replay mode. It tries to simulate the same activity found in the source workload. So if there's a pause after a query, it will be maintained in the replay as well. Other tools, we have distributed replay, which was introduced in SQL Server 2012, and it works pretty much as OSTRES, but it also has the ability to run replay on multiple clients. So it is actually capable of distributing pieces of the workload to multiple nodes with central controller nodes that synchronizes all the nodes. We have the same ability to maintain the query rate found in the source workload as with OSTRES, but this time it's not called replay mode, it's called synchronization mode. So yay, consistency. And okay, so what happens if we move to the cloud? Will these tools be still helpful? Let's see how things work in the cloud. So first of all, cloud is not a word that describes all possible scenarios, because you have many possibilities, many ways, many possible meanings of the word cloud. Let's see all these scenarios. On the left here we have private cloud or on-prem. And here, basically, you control everything in your stack. So everything that goes from networking to the application is under your control. But if you move to the cloud, the first step is infrastructure as a service. And here you have control of everything that goes from the operating system app. So you can control Windows, you can control SQL Server and the data and the application. But you have no control on what's below this level. And then you have a platform as a service. Here you lose control on the operating system. So the tools that you can use to benchmark here will be different from the tools that apply in infrastructure as a service. And then we have the last step, which is software as a service, and DBAs have no interest in this. So let's see how things work in the cloud. First of all, infrastructure as a service. This is basically a VM in the cloud, so nothing changes here. All the tools that you can use to benchmark on-prem still work in an Azure VM. It's the same. It's a virtual machine in Azure, so it still works everything. And platform as a service could be two different things. The first one is a managed instance, and this means that you have a whole instance that you can control where you have sysadmin rights, but you don't have control on the operating system. So this means that you cannot write directly to the file system, and this limits our options for capturing a workload. Traces are not supported, and extended events are supported, but you cannot write to the file system. So what you can do is you can write to a blob storage file target, or you can stream the events using the streaming API for extended events. And performance counters are not supported directly, but what you can do is you can query some of the performance counters through T-SQL, and you only have access to the subset of performance counters that are exposed through T-SQL. Moving to SQL database, here we have even less control because we don't have access to the whole instance. We have access to only one of the databases. Still have no way to write directly to the operating system, so traces again are not an option. And extended events, the only option we have here is writing to a blob storage, because streaming extended events requires some permissions at the instance level, so they're not really an option here. Okay, so we have some real trouble here because the tools that we have known for a long time won't work in the cloud. So what do we do here? Do we have to accept that there's no way to benchmark here? Of course not, because what I did is I created a tool which is called Workload Tools. It is an open source project that you can find on GitHub under github.com/spaghettidba/workload tools. And it is a project that takes care of all the aspects of benchmarking. So capturing workload, replaying a workload, and analyzing a workload data. It has two unique features that you will not find in any other benchmarking tool that we have seen so far. And the first one is the ability to work against an Azure SQL database or an Azure managed instance. And also it has the ability to perform real-time replay. So what you can do is point the tool to your source instance, so probably your production instance, and point it to a test instance and capture the queries from production and replay them against a test in near real time. The main concept in workload tools are the listener and the consumer. Basically, the listener is something that is able to capture the queries in the workload using the underlying technologies, so SQL trace or extended events, or if it is a saved workload, a file, and reading the events from these technologies, it will be able to forward the events to a list of consumers subscribed to the listener. And each of these consumers will perform different actions. So at the time we have a file consumer, which is able to write the events, so the queries, to a file that contains the whole workload, and this will be useful for replaying at a later stage. And then we have an analysis consumer, which is able to analyze the events captured from a workload, and then a replay consumer, which is able to replay the event coming from a listener. It is super easy to configure because you don't have to remember countless command line switches. All you have to do is write some configuration values to a JSON configuration file that you can save on your computer for later use, and you can modify it for adjusting it to different environments. And if you are not comfortable with using configuration files, another thing you can do is script the use of the tool via PowerShell. So it is a library, a DLL library that you can instantiate from PowerShell or any other scripting technology and script to run your workloads. And also for visualizing data, you have two built-in ways. One is called Workload Viewer, which is a GUI tool to visualize the performance data for a single benchmark, so to show you the workload analysis, or a workload comparison, which involves two benchmarks. You also have a Power BI dashboard that you can point to the analysis database to have custom analysis on the data that you captured from the analysis database. Okay, so enough talking. I could show you how the tool works, right? So we will have a first demo, and this demo I will show you how to analyze a workload. So basically I will point the tool to a production workload where I will capture all the queries, and I will analyze the workload in order to find interesting results, like the expensive queries, or how the workload behaves over time. And how to capture? I can use different technologies for capturing SQL trace, extended events, depending on the version I'm working on. And I don't have to configure the trace or the extended event session because Workload Tools takes care of everything. And also for analyzing the workload, I don't have to write complex queries or running custom reports because I have a tool for this, and I will show you how this works. So let's go to our demo environment. Oh, let's go back here. So, okay. This is a virtual machine. In Azure, what we have here is two instances of SQL Server, a SQL Server 2016 and 2019. And what I will do is I will run a workload, a synthetic workload against this DS3 database. And the workload I will use is the DS3 workload, the DVD store workload, which is a tool provided by Dell to simulate workload. It is a synthetic workload that simulates sales on a DVD store, so an online DVD store. It is something that shows its age because it would be something like Netflix today. It was probably coded when DVDs were still a thing, but still doesn't matter. So what I will have to do first of all is start the synthetic workload so that I have something to capture. I will capture the workload against this SQL 2016 database first. So here I'm running this workload, and it is buying DVDs like crazy. And now I have to use my workload tools to capture and analyze this workload. How do I do this? So as I said, it is a command line tool which is called SQL Workload. I don't know whether that is big enough. So it is called SQL Workload, and it accepts a single parameter, which is the name of a JSON file. So let's go and see this JSON file that contains the configuration. It is called Analyze, and it contains one section that is about the listener. So here I will have to configure the listener, and I'm using a listener of the type extended events, but I could use SQL Trace or file listener. And all I have to do is configure some connection properties to point it to my instance. So I'm telling it to go to SQL 2016 to the database master and filter only the events for the database DS3. Also, here I have a section for the consumers. Here I have only one consumer, but I could have multiple consumers. And what I'm doing here is I'm using an analysis consumer, and I'm using this connection info, which is used by the analysis consumer to know where to write the analysis data. So all the data that gets analyzed from the workload gets written to a database on SQL 2019 on this database on a particular schema, the schema capture. And the data is written every 60 seconds, sorry. So we have different intervals every 60 seconds that contain the aggregation of the performance data for that interval. So if I run this, let's see what happens. I can run this, analyze, and it starts capturing the workload. And every 60 seconds, it writes the analysis data to this schema. So the SQL Workload 1, as I told it to write, I have some queries here. So the capture schema with some tables that contain the information captured for this workload. So I will not wait to have some data flowing to this database, because obviously it takes some time. Just to have some data to show you, I would have to capture multiple intervals, and we don't have time for that. So I will show you how the data works once it is written to the database. So what I can do here is stop the workload, stop the listener, and what I can do is show you how the data looks once it is inside the analysis database. And I will do it by running this workload viewer that shows you how the data looks inside the database. So here at the top we have filters for filtering the data that it shows, and here we have 3 charts for the CPU over time with the offset from the start of the workload, so 5 minutes, 10 minutes, and so on. And this is what the CPU, the aggregated CPU for the whole workload inside the interval looks. And then we have the aggregated duration for a particular interval, and here the offset from the start of the workload again, and here we have the number of batches per second. If we want, we can filter this with the filters we have at the top. And then we have a queries tab that contains the list of all the queries that we have captured for this workload, and they are normalized, so as in clear trace the constants are removed, and they are summarized here. So for the overall workload, they are hashed, and if I click on one of the hashes, I can see the actual query. This is one of the possible queries for this hash with the actual values, so not the one with the placeholders. And I can sort the data for duration. So if I want to analyze my workload, I now can tell for sure that the queries that lasts the most, that has the highest duration in milliseconds, is this one. And I can see details for this particular query by double-clicking it, and I see the duration over time and statistics for by application, database, host, and login, and I can see the query text here. So it is a way to visualize the data for a single workload. Okay, moving on, another thing that I could be doing with Workload Tools, so going back to the slides, we have a second type of demo, and in this case, if I want to replay a workload, I will have to capture the workload first. So I will have to decide which type of file I will use for capturing the workload. I could have used SQL Trace or Extended Events format, but they both have some shortcomings. SQL Trace uses an old API that is not available on 64-bit environments, so it's not really suitable for high-scale workloads. And Extended Events is not suitable for all the versions of SQL Server. So the only option here is using a different standard for saving the workload. And what I chose for this is a SQLite database. So what we will do with this next demo is we will capture a workload and write it to a SQLite database that we can use later for replay. So let's go back to the virtual machine. What we can do here is go to the second demo, and what it does here, again, we have this SQL workload with the capture JSON as the argument. Let's go and see the capture JSON, and it contains a listener. Again, it is a listener of the type Extended Events. It is pointed again to SQL 2016, filtered for DS3 database, but this time we are writing to a file. So we have multiple consumers, and the first consumer is the analysis consumer, as we had before, and then we have a second consumer, which is the workload file writer consumer, and the argument here is the output file, so where to write the workload, and it is a SQLite database. So let's go and do this. So again, if I go here and I start my workload, what I can do with capture, it is saying writing event data to this particular file, and this file will contain a SQLite database with all the events that I am capturing. 1,000 events saved, 2,000 events saved, and so on. So let's go and see where the file is. It is this SQLite file, and we should see this size going up because it's right into this file. So it is indeed increasing. So what we can do here, we can inspect this SQLite no. I don't have the tool for this, but there's a tool to inspect this SQLite database. You can go inside and see that it actually is a SQLite database. So what you can do is use that particular file if you want to use it as a source for a replay, which is what we will do right now. So let's go to the next demo. Next demo is replaying a workload. So before we go to the replay, we have to decide a couple of things. like we will have to decide whether to consume the query results or not. This is one of the things that has a huge impact on the workload, especially when you're moving to Azure or any cloud scenario and the application is staying on-prem. The latency will go up, so it's important to consume the results because it becomes a non-negligible part of your workload. So if you want to assess the performance of a workload that you're moving to the cloud, you better do that from a location which is already closer to the database, as could be an Azure VM instead of a computer running on-prem, which has a higher latency to the Azure SQL database or managed instance compared to a computer that is already on Azure. If a query fails, you have to know that up front because it's something wrong with your target environment. And also before you start with a replay, you have to set up the environment. So you will have to have a database backup restored to the target environment in order to have the workload running against the same exact data. Okay, so let's go and try to do this. So moving to the next demo, replay. So this time I will have two instances of SQL workload running. It will be the replay. Oh, sorry. Something is wrong here. My mouse is not moving. Can you hear me?
Yeah, I can hear you.
Okay, something is wrong here because my mouse is not moving. You see it frozen as well?
Yeah, it does not look like it's moving.
Is it moving?
No, the mouse is not moving.
Okay. So let's see if I can do something about it. Can you please take back control?
Sure, absolutely. 1 second. All right. Let me make you a presenter again.
No, my mouse is not moving. I don't think it has anything to do with the mouse itself.
Can you try hitting the keyboard? Maybe that can change something.
Okay, so it's a mouse. Let's see whether a different mouse works. Okay, it works. Okay, so show my screen.
And that's the correct screen. Or the same screen as last time.
Okay, so we're back online. Okay, so what we want to do here is have two instances of SQL workload. The first one will perform the replay, so it will capture the source workload pointed to the SQL 2016 and will replay against SQL Server 2019. So this is a listener, the listener section, so nothing changes here, but on the consumer part we have an analysis consumer that will perform the analysis on the source, and we are writing to the SQLite database. And for the replay, what we do here is we point the listener to a file workload listener that loads the events from a SQLite database that we have saved up front, and then the consumer will have a section for replaying the workload. So this time it's pointed to an Azure SQL database and username and password. Don't bother copying the password. I will change it right after the presentation. And pointed to this database name, and it will replay to this one. And for the analysis, it will analyze the workload while it is replaying it. So it will write to this SQL 2019 database. So to analyze the data on the target instance, what it does, it has a listener pointed to where we are replaying. So it has an extended events workload listener pointed to the Azure SQL database. And this time it needs an additional parameter for where the Azure blob storage that contains the extended events file is located. So we need to configure this up front on the Azure SQL database, and it can be used by our extended events session. And then the consumer is the one that writes the analysis data captured from the target database to the same database but in a different schema, so it can compare the two. So if we run this, I'm not going to do this because we don't have time for that, but what I can show you here is how this compares the two. So the source workload and the target workload, and you have the two together. So green is the baseline and black is the benchmark, so the replay. And you can see how the two compare in terms of CPU, in terms of duration, in terms of number of batches per second. And you can filter those on application, database, and host. And also if you go to the queries tab, you can see how the two compare. So if you go here, you can see regressions by clicking on this. The difference on duration between the two workloads, you can sort by this, and you can see that this is the query that has regressed the most in terms of duration. So you can go here, double click, and see how this goes in average duration in time, always from offset minutes from the start of the workload. And here it is broken down by application, database, and host, and login. So this is how you perform a comparison of two benchmarks. One of the other interesting things that you can do with Workload Tools is replay in real time. So what we have done here, so replaying starting by a saved workload can be done by replaying in real time, so skipping the recording phase. And this is useful for when you have workloads that last for a long time. So you want to cover a very long period for the capture, and that would be gigs and gigs of trace files or extended events files, and it's not really acceptable. If you try to analyze gigs of trace files with OSTRES, with read trace, you probably know that at some point it crashes because it cannot handle huge files. So a way to avoid this is to run the replay and the analysis in real time. So you have one instance pointed to the source database and one instance pointed to the target database, and how you configure this is like this. So let's go to real-time replay. Here we have, let's close this, two instances. The replay is configured like this. You have a listener pointed to the source and extended events to capture the source here. And then the consumer for the replay and the analysis. So it replays on the fly does not need to write to a file first and replace directly to our Azure SQL database. And at the same time writes the analysis to a database with a capture schema. And then we have a second instance of SQL workload for the analysis pointed to the Azure SQL database. So here we have extended events workload listener pointed to the Azure SQL database with a blob storage for storing the events. And then the consumer here only has to analyze the data and write it to a database, an analysis database with a replay schema. So what we have done before, but right on the fly. If you do this, you can do this for a sustained amount of time, and this works really well when you have very big workloads. So what I have done here is I had a customer who had to migrate from SQL Server 2008 to SQL Server 2017, and they wanted to know where the possible regressions were, and the workload was very long potentially. I had to capture something like weeks of data, and I used this tool. What I will show you here is like 7 hours of capture, and it looks like this. And you can go here and zoom in for a particular part of the workload, and here you can go and zoom in here and see this particular part and see how performance compares, and you can see the queries that regressed. You can go here by duration and see that this is the worst in terms of regression and so on, and see the details. And this is particularly useful in scenarios like this. So summing this up, benchmarking used to be super hard, but using workload tools now it is incredibly easy. You just need to configure a couple of JSON files with your connection properties, and it's ready to use for capturing, replaying, and analyzing your data. So that was the content I had for today, and if you have questions, I'm happy to answer them.
All right, great. We have one question still left in the queue. A couple others I answered throughout. So for the first question, there we go. You may have exclusivity in test environment, but unlikely to have full control on prod, which may be running other stuff, VMs, SQL instances, SAN, LAN traffic, etc. So you must be sure to recognize the apples and pears comparisons, correct?
Right. So the way to do this is to rely more on the data that you capture along with the queries. So the performance data relative to the specific queries, like duration, CPU, reads and writes, which is more interesting than the raw CPU on the machine. And filtering down by application or by database, you can be sure to capture exactly what you're after.
Cool. Next question is, company is keen that UAT does not have real data due to governance, security considerations, etc. Do you have any advice on a tool to generate synthetic data with the same shape as production?
Okay, so the problem with obfuscated data or synthetic data is that it does not work really well with a production workload because the production workload contains references to production data, also in the queries and in the parameters. So the only way to benchmark with synthetic data or obfuscated data is to have application level benchmarks. So you have to create your own test suite to generate benchmarks on your obfuscated data.
All right, great. That is all the questions that we have today. Thank you for presenting today, Gianluca. And
Thank you very much.